Hi, welcome back. So in a previous video, we talked about this function, f of x equals x squared plus 4x plus 1, and we used the general form for the vertex, which is that x is always at negative b over 2a, and the y-coordinate of the vertex is the functional output at that point. But there's another form for the equation of a vertex, for the equation of a parabola called the vertex form. And the vertex form looks like this. It looks like f of x is equal to a times x minus h plus k. And if you have got your quadratic formula, or your quadratic function rather, in this form, then the vertex is at the coordinates h, k. So, for example, the general form for the parabola that we've graphed previously is f of x equals x squared plus 4x plus 1. The vertex form, because I know where the vertex is for this one, is at f of x equals x minus negative 2, so x plus 2 squared, plus k, which is plus negative 3, so minus 3. Now, let me show you. I want to show you how to go from the general form to the vertex form, so that you can find the vertex of a parabola without going through the vertex form, or without going through this work. Or if you've got this form, you will know where the vertex is. Okay. This form can also be very handy for finding those x-intercepts that I was talking about in the other video, and I'll show you how to do that. In fact, let's do that. Well, let's do that after we do this work. Okay. So, we're going to do something called completing the square. And what we're going to do is we're going to work with x squared plus 4x plus 1. And I'm going to complete the square on one side of this equation. So the first step is to group my x's together inside a set of parentheses, but I'm going to leave a blank. And then I'm going to copy the rest of my formula, but I'm going to add something, so I need to then subtract something. Now, if I had something other than 1 in front, I would factor that out of these x's at that point. In this case, I don't have anything but a 1, so we can ignore that. I'll do an example with a coefficient that is not 1 in a minute. Now, I'm going to add something here, and what I add is always the same thing. I'm going to take whatever is in the middle and divide it by 2. So I'm going to take this 4, and I'm going to divide it by 2, and then I'm going to square it. So 4 over 2 is 2, squared is 4. Now I added 4. I'm not allowed to arbitrarily add things, so I have to subtract 4. So now what I have is I've rewritten my function as x squared plus 4x plus 4, and we're going to go ahead and subtract 3 here, or combine like terms and get minus 3. This trinomial factors, and it always factors the same way because this guy is always a perfect square trinomial. So he is going to factor as the square root of the first guy, then this sign, and then the square root of that guy. So x plus 2 minus 3. Except it's x plus 2 squared minus 3. So let's do it. Let's try that again. Let's try that with this quadratic function. Let's rewrite in vertex form the function g of x equals 6 minus x squared. So the first thing I'm going to do is rewrite this in standard order. Now I can see I've got a -1 for my leading coefficient. So I'm going to factor that out of just the x's. So that's a -1 times x squared plus x. And I'm going to add something, plus 6 on the outside. And if I add something, I need to subtract something. So what am I going to add? Well, I'm going to take this 1, because there's a 1 here, and divide it by 2 and square it. So 1/2 squared, which is 1/4. Now, what have I actually added? What I have actually added is -1 times 1/4. So I'm going to subtract a -1 times 1/4. So my function now can be rewritten as -1 times this trinomial factors, x plus 1/2 squared. Now I've got plus 6 minus a -1/4, so that's 6 plus 1/4, which is 25/4. So now my vertex is at the coordinates -1/2, 25/4. Shall we check it? The easiest way to check this is with Desmos. Yeah. Okay, so let's graph our parabola. And we know it should be an upside down parabola. Whoops. Minus x plus 6. And I can touch that point right there. And sure enough, Desmos tells me that is indeed my vertex. Okay. So now, I told you that this form would also be handy for finding x-intercepts. So let's do that. So these two are pretty easy to find. And if we wanted to, we could factor that guy and find them. But let's do this instead. So let's remember, so let's go ahead and do something else here. But let's do this in the next video. So I'll come back in a sec.